Welcome to Lesson 3.2, Piping Shell Data into Claude. I'm going to make one promise right now. If you've ever found yourself copy-pasting terminal output into a browser tab, opening Claude.ai, pasting it in, reading the response, and then doing the whole thing again for the next file, by the end of this lesson, that habit is gone. We're going to replace it with shell scripts that do the same job faster, without you touching the keyboard after the first run. This lesson sits inside Module 3, Agentic and Headless Workflows. The big idea of this module is that Claude Code isn't just a chat interface, it's a command line tool, and command line tools compose with other command line tools. That's what we're building today. Specifically, we're going to pipe 3 types of shell data into Claude: Git diffs for code review, application log files for error analysis, and pytest output for test triage. Each one produces structured JSON that downstream tools can actually use. Let's start with the problem. Here is the manual workflow most developers use when they first try to get Claude to review their code. You run git diff head_1 in the terminal, you select all 400 lines, you switch to your browser, you open Claude.ai, you paste the diff, you read the response, you switch back to the terminal, and then you do it again for the next commit. That loop, terminal to browser and back, is 2 context switches per commit. For a 20-commit sprint review, that's 40 context switches before you've automated a single thing. But the context switches are actually the smallest problem. Look at what this workflow produces. Nothing persistent. The review lives in a browser tab. There's no file, no JSON, no record. When a teammate asks, "What did Claude say about that payment service change last Tuesday?" you have nothing to show them unless that browser tab is still open. And it's completely incompatible with CI. A GitHub Actions runner does not have a browser. The moment you want this to run automatically on every pull request, the entire approach hits a hard wall. There's also a silent failure mode that catches people off guard. If your diff is large, say a refactor that touches 50 files, it may exceed the pastebox's character limit. The text gets silently truncated. Claude reviews an incomplete diff and returns a partial review. You don't know what was dropped. So the summary on this slide is accurate. 20 commits, 40 context switches, 0 persistent output. The manual approach doesn't scale, doesn't persist, and can't run without a human in the loop. Before we write any code, we need one mental model. Everything else in this lesson builds on it. Claude Code's -- print flag makes Claude a proper Unix process. Read input, write to output, send operational messages to stderr, and exit with a meaningful code. Once you think of it that way, you can compose it with every Unix tool you already know. Let me walk through the 4 boxes on this slide from left to right. Box 1, your shell command. This is git diff, tail on a log file, pytest output, anything that writes plain text to stdout. The one rule here is no color, no ANSI escape codes. We'll talk about why in a moment. Box 2, is TTY0 detection. When Claude --print starts up, it checks whether file descriptor 0, that's SDN, is connected to a terminal or a pipe. If it's a pipe, Claude reads all of SDN and appends that content to the end of your prompt string, separated by 2 new lines. The effective message the API receives is your prompt text, 2 new lines, then all the SDN data. There is no separate --SDN flag. This is automatic, always on, and non-optional. This has one important implication. If you run Claude --print at an interactive terminal without piping anything, it waits for you to type and press Ctrl-D. This is the most common cause of CI hangs. Your pipeline stalls waiting for keyboard input that never arrives. Always make sure SDN is a pipe in automated contexts. Box 3, the Claude --print invocation. 2 flags matter most here. -- allowed tools with an empty string removes all tool access. By default, print mode still has access to edit and bash. If your review prompt is underspecified, Claude might decide to apply its own suggestions, which means file writes during what you thought was a read-only analysis run.
empty tool string equals 0 side effects. Use it in every CI pipeline. Box 4, outputs. This is the contract. Stdout gets the response text. Stderr gets operational messages, rate limit warnings, token counts, authentication errors. Exit code 0 means success. Exit code 1 means an API error, including token limit overflow. Exit code 2 means an authentication failure. The 3 insight cards at the bottom summarize this. No separate -- in flag, -- allowed tools empty string is essential, and stdout is not stderr in CI. That last one catches people constantly. We'll come back to it.
Now let's look at the full picture. All 5 stages of the pipeline, from shell command to output file. Stage 1, gray, shell data sources. 3 types in this lesson: git diff for commit review, tail on app.log for log analysis, and pytest output for test triage. The constraint from this stage is plain text only, no ANSI codes. Stage 2, orange, pre-pipe guards. These are the safety checks that make the pipeline CI safe. First, WC-C measures the payload size. Then, head-C 12,000 truncates anything over 120 kilobytes. That's approximately 30,000 tokens, well within Claude's context window with room left for the prompt and response. The sed command strips any ANSI escape codes that slipped through, and grep-vff filters the commit list against the state file. That warning callout between stages 1 and 2, that's the ANSI failure point. If you use git diff with -- color always, the color codes survive the pipe and end up in Claude's stdout. When your pipeline tries to run JQ on the output, it throws a parse error on the escape sequences. This is the most common works on my laptop breaks in CI failure in this pattern. The fix is always use git diff -- no color. Stage 3, dark, Claude-print. This is the core. Is ADI 0 detection fires here? -- allowed tools empty string removes side effects, and exit codes are load bearing. Stage 4, blue dashed, the Anthropic API, external to your system, behind HTTPS. The dashed border signals that this is outside your control. Rate limits fire here. Token limits are enforced here. Stage 5, green, outputs. Reviews.json contains the structured JSON review. The jq.risk field becomes the CI gate. The SHA state file records what was processed. The annotation at the bottom of this slide is the one architectural decision that makes batch pipelines resilient: the state file. We'll dig into that in the implementation. Let's look at the actual script. 18 lines. Nothing pseudo, nothing placeholder. This is the code you'd run today. Line 2, set-EUO pipefail. This is the single most important line in any bash pipeline. The -E flag aborts the script on any non-zero exit. The -U flag treats unset variables as errors. The -O pipefail flag propagates failures through pipes. Without this one line, a Claude.print call that fails and returns exit code 1 gets silently swallowed. Your script exits 0, your CI step shows green, no review is produced, nobody knows. Lines 4 and 5, ref and max chars. Ref defaults to head-1 if no argument is passed. Max chars is 120,000 characters, which is our token budget ceiling. Line 8, the diff capture. Note the -- no color flag on git diff. This is non-negotiable. Never pipe color diff output. Lines 11 to 13, the amber highlighted section. This is the token budget check. The $#diff notation in bash gives you the character count of the diff variable. If it's over 120,000 characters, we truncate. Note that head-C truncates bytes, not characters. It may split a multi-byte UTF-8 character at the boundary. In practice, the Anthropic API strips malformed UTF-8 at the tail rather than throwing an error, so this is acceptable. Lines 16 to 18, the green highlighted section. This is the pipe itself. Echo $diff pipes the diff to Claude.print stand-in. -- allow tools with an empty string removes all tool access. The prompt specifies the JSON schema. This is the contract. Whatever schema you put in the prompt is what you parse downstream with JQ. The annotation cards on the right tell the story. Fail fast. Set-EUO pipefail is what makes non-zero exits visible. Token budget, 120K tokens gives you roughly 30K tokens of headroom. The pipe,
echo $diff is the simplest way to feed data to standing. And the JSON contract, your prompt schema, is the API between Claude and your downstream tools. One production addition I'd make to this script, add to append redirect to /tmp/claude-review.log on the claude.print call. That captures all the standard error operational messages, rate limit warnings, token counts, to a log file without contaminating your JSON standard.
4 failure modes. Each one has broken a real pipeline somewhere. Let's go through them quickly. Failure 1, ANSI escape code contamination. You add -color = always to get diff for readability. The escape codes flow into Claude Print's input, which is fine, but they end up in the stdout response. When you pipe that response to JQ throws parse error, invalid numeric literal. The sequence \x1b(32m) looks like a broken number to the JSON parser. The fix? Always use getdiff-nocolor, or add the said ANSI strip as a belt and suspenders defense. Failure 2, context overflow, silent CI pass. A large refactor produces a diff over 200 kilobytes. Claude Print receives more tokens than the context window allows. It exits with code 1 and writes the error message to stderr. If your script doesn't have set-EUO pipefail, the non-zero exit is swallowed. The script exits 0. The CI step shows green. The review file is empty. No one notices until a high-risk change ships without review. The fix: WC-C before you pipe, head-C12000 to enforce the limit, and always check $? after every Claude Print call. Failure 3, Anthropic API key billing override. This one specifically catches people taking this course. If you set an API key during Module 8 work and forget to unset it, every Claude Print call in every Module 3 lesson switches from your Pro subscription to API credits. Claude Code doesn't warn you, it just switches silently. You discover it on your billing dashboard. The fix: before any Module 3 session, run echo $Anthropic API key. If it returns anything other than empty or not set, unset it. Failure 4, stateless batch loop. You write a for loop over the last 20 commits. It runs successfully for 10 commits, then you kill it. You restart it. It starts from commit 1 again. 10 commits are reprocessed, token costs double, and you get duplicate review files. The fix: the .claude reviewed state file, 1 SHA per line. Use grep-vff with a capital F flag to filter processed commits. The -f flag treats each line as a fixed string, not a regex pattern. This matters because hex SHAs are valid regex patterns that could accidentally match other SHAs without it. This slide is a reference. Let me hit the most important items on each side. On the do side, the green column, set-EUO pipefail, plus trap error. This is the foundation. The trap command logs the line number where the failure occurred. Claude failed at line 42 is actionable. Something went wrong is not. Get diff-nocolor, always. Make this a habit. If someone else's git config has --color = always, their run will fail without it. Separate stdout and stderr. Never use 2&1 on a Claude-print call. Claude's operational messages are English prose, processing token stream, which is valid text but not valid JSON. Merging them into stdout breaks every JQ call downstream. On the don't side, the red column, 2&1 on print calls. Just covered this. Don't do it. Unchecked exit codes, the silent CI pass failure. You now know the consequences. No -- allowed tools empty string in CI. Without this, a vague review prompt can trigger file modifications in your working tree. In CI, this can trigger pre-commit hooks and create confusing downstream failures. Keep this slide bookmarked. The first time you're debugging a broken pipeline, the answer is almost always in the red column.
This diagram shows exactly where each commit goes when it enters the batch review pipeline. Read the happy path left to right. Unprocessed. This is every commit SHA returned by GitLog that isn't already in the .cloud reviewed file. Size checked. The character count is measured. If it's over 120 kilobytes, the commit detours to truncated, A warning goes to stderr, and the truncated diff rejoins the pipeline at the piped state. This is a detour, not an error. Piped. Cloud_print is invoked. If Cloud returns a non-zero exit code, the commit drops to Cloud_failed. The retry loop fires, waiting 2, then 4, then 8 seconds between attempts. After 3 failed retries, the commit goes to logged_skipped. That's a terminal error state, indicated by the double border on that box. The errors counter increments, and the batch continues with the next commit. Received. stdout is captured. Parsed JSON. JQ validates the response. If JQ fails, which happens when Cloud wraps the JSON in markdown code fences, it goes to parse error. The sed fence stripping command handles the common triple backtick JSON case. SHA done, the happy path terminal state, also double bordered. The JSON file is written to the reviews directory. The SHA is appended to .cloud_reviewed. This commit will never be processed again. The legend at the bottom. Green is happy path. Red is error. Orange is detour or warning. Double border means terminal. The key insight from this diagram. The state file is the checkpoint. Every SHA that reaches SHA done is safe to skip on restart. The pipeline is idempotent by design.
Here's how the lesson's scripts graduate into a real production workflow. This is a GitHub Actions pipeline that runs automatically on every pull request. Step 1. Checkout with fetch depth 0. You need the full Git history. Without it, git diff origin base.head fails because the base branch reference isn't locally available on the runner. Step 2. Set up node and npm install for Claude Code CLI. This installs Claude on the Ubuntu latest runner. Step 3. The core pipe. This is review diff.sh logic, inlined for clarity. Git diff with -- no color, piped through head-c 120k, piped to Claude with -- allowed tools empty string. Note, in this CI step, Anthropic API key is correctly set as a GitHub Actions secret. This is one of the explicit exceptions where the API key is appropriate. A CI runner doesn't have a browser login session. Step 4. JQ extracts the risk field and writes it to GitHub output, which is the mechanism for passing values between steps in a workflow. Step 5. GitHub script posts a formatted comment on the pull request with risk emoji and the review summary. Step 6. The gate. If the risk field is high, the step exits with code 1. If this step is configured as a required status check in your branch protection rules, the merge button is blocked until the risk level drops. The 3 outcome cards on the right show what happens in practice. Low risk, a green comment appears, nothing is blocked. Medium risk, a yellow warning annotation. High risk, the required check fails, the merge button grays out, and a senior reviewer is needed.
Five heuristics. These are the principles you apply automatically after this lesson becomes habit. 1. Claude print is a Unix process. Treat it like one. Stand in, stand out, stand error, exit code. If you wouldn't trust a bash command that ignores its exit code, don't trust Claude-print without checking $?. 2. Pre-pipe guards are not optional in CI. WC-C before, head-C 12,000 for truncation, sed for ANSI, and set-EUO pipefail. These 4 lines are the difference between a script that works on your laptop and a pipeline that survives a GitHub runner. 3. -allowed tools empty string removes all file and shell access. Every CI pipeline that uses -print for analysis should pass this flag. The word analysis implies read-only. Enforce it explicitly. 4. State files make batch loops resumable. Append the SHA only on confirmed success. The SHA on success invariant is critical. If you append before validating the JSON, you'll have SHAs in the state file for commits with missing or invalid review files. Always, write JSON, validate with JQ, then append SHA. 5. Anthropic API key overrides pro, silently. Add echo $Anthropic API key as the first line of every cloud-related script. One line that eliminates the billing surprise entirely. If you remember nothing else from this lesson, remember heuristics 1 and 5. Those are the 2 that cost real money or real time when you get them wrong.
A few resources worth bookmarking. The Claude Code CLI reference at docs.anthropic.com is your authoritative source for flags, exit codes, and authentication modes, more current than any course material, including this one. The JQ manual at jqlang.github.io covers the 3 operations you'll use 90% of the time: .field for extraction, -r for raw string output in CI, and .bracket for arrays. For the GitHub Actions integration, the actions/github.script repo shows how to post PR comments and create review annotations programmatically. The 3 next cards on the right are where this lesson feeds forward. Lesson 3.3 adds write permission, same pipe pattern, but -allowed tools edit allows Claude to apply type hints directly to Python source files. Lesson 3.4 closes the feedback loop. Pytest output pipes into Claude, Claude generates fix instructions, and the pipeline applies them automatically. Lesson 3.5 is the full GitHub Actions integration that builds on everything in this lesson. The homework from the lesson article is worth doing today. Write weeklyreview.sh, wire it to a cron schedule trigger on GitHub Actions, and let it run. You'll have automated sprint reviews next Monday morning without lifting a finger. The pipe is the API. That's the one sentence I want you to remember from this lesson. Claude Code's print mode isn't a special AI interface. It's a Unix process. You pipe data in, JSON comes out, you check the exit code, and you compose it with everything else in your shell toolkit. Look at what you built today. ReviewDiff.sh turns a Git diff into a structured risk review. AnalyzeLogs.sh turns a log file into a categorized error summary. TriageTests.sh turns pytest output into actionable fix hints. BatchReview.sh runs all of that over 20 commits, survives interruption, and produces a review file for each one. And dashboard/progress.py shows you what's happening in real time using a rich terminal display. None of these scripts require a browser. None of them require you to be present. They can run in CI, on a schedule, in a pre-push hook, or whenever you choose to trigger them. That's the shift this lesson is about. Not Claude is a chat tool I use manually, but Claude is a component in my automation pipeline. Same as grep, same as JQ, same as any other Unix process. Lesson 3.3 is next. Same pipe pattern, write permission enabled, and Claude starts modifying your actual source files. See you there.